midterm. So it's week 7, midterm. I was asked about it before class, about what we're going to be doing, and it'll be a project. I think it'll be Squid. I'm really heavily leaning towards Squid. We've got, what, spring break starts on the 19th, right? 16th?
16th to the 19th, I thought.
Yeah.
Oh, to the 19th? Okay, well, whatever. Anyway, so this week we'll be doing file permissions. I may start you guys on Squid, maybe getting it installed. And then next week, we'll go through Squid, and then the midterm will be to just get that in. It's not super hard to get the basics set up, and if you don't get it, it's no big deal. I will put in all that stuff. You know, if you just send me like a progress report of what you're doing, you know, I'm totally cool with that. You know, like I was saying earlier, this is an introductory class, and I want it to be fun and enjoyable. So if you're a little bit behind, I'm not worried about it. Just let me know. You know, more than anything, it's just getting in there and playing with it, using it. I growing up with computers, like, I would go in and just do stuff because it was fun. I played video games and stuff, but I'm not a big video gamer. I like fiddling with things and making my system do things that most people can't make their systems do. I'm like the guy who builds a rock crawler and does really technical stuff with their vehicles. I like doing that, and it translates very well into jobs because with any operating system, getting it to do something and do that one thing well, it serves you well in the business world, because you may have an application like WordPress that you need to install and get running and working. So, you know, for me, I find that really satisfying to go in and dig through things and get them going, and I hope that you guys are getting that out of this, and that's my goal, and so that's why I'm not putting any pressure for getting things in like super on time. Just like communication is key, obviously. So if you guys are working on it, I'm cool with it. I'm willing to work with you guys. So thank you all who are here. Awesome, and even online too. So good to see everybody participating. I don't know why I have this thing up. I'm not sharing anyway, so it doesn't matter.
Hey, I'm thinking about letting some pizza. You guys want some? Anybody?
Yeah.
Yeah?
Yeah.
Okay.
All right, I'm going to share my screen, and we're going to get started and present to everyone. Hopefully everyone can see me. So a while back, we went over the file hierarchy stuff. I'm actually going to CD to root, just to show all of the directories in the root of the file system. And this little slash means you're in the root of the file system. And quite a while back, you know, we talked about what these outputs of, like, you know, ls-l mean. And I talked about, like, these are permissions over here on the left-hand side. And I didn't really go into what those meant. And in Linux, it's actually pretty easy, but they can be kind of complicated too. And, you know, if you've never done file permissions at all ever before, even on Windows, you know, it's not too terribly different than Windows, but if you've never done it before, it's a little bit weird. On Linux, you have 3 different sets of permissions by default. You have the owner of the file, you have the group of the file, and then you have everyone, global permissions. And those, let's just take this directory, for example, home directory. The D indicates that it's a directory, and then we have RWX, RX, RX. And you notice that that is a pattern that repeats itself. And this is the permissions for the owner. The owner happens to be root. These are the permissions for the group, which also happens to be root. And these are the permissions for everyone else on the file system, or on the not just the file system, but the system in general. And what this means is these are actually fairly well laid out. They're not in binary, but these are actually binary permissions. And so what that means, there's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9 bits there. Well, actually, there's 9 positions open for a 1 or a 0. And so there's a flag, basically, where this is nothing, that's a 0, and where there's an X, that's a 1. And see, this one this is RWX and has no permission for anybody else. So the R is for read, the W is for write, and the X is for execute. Now what's interesting about execute on a directory is that execute is for browsing the directory. I can have read access to a specific directory, but not be able to view anything inside of it because I don't have execute. For files, you can actually change. I'm going to go back to my home folder. We're going to ls this, and let's say I'm just going to create a shell script. You guys don't really have to know what I'm doing. I'm going to call this xscript.sh. I'm going to say it's interpreter's bin bash, and I'm going to say echo hello world. Now to run this script, if I do an ls and I grep for xscript, I probably want to do an ls-l to see the permissions on it. We can see that it has read, write, read, and read for root. And that's because I'm root. I created the file, so I have read, write on it. But I can't just run it. I can't just say xscript. It'll say permission denied. Well, I'm root. Why can't I run it? And that's because I don't have the execute permission. And execute basically turns a file into an executable. So I do a chmod to change the permission on the file, and I say +x, I add the execute bit to xscript.sh. Now if I try running it, it runs and says hello world. So unlike Windows, where there's a predefined type of binary or something that you need to run in order for it to recognize it as an executable, in Linux, anything can be run as an executable. I could take this JPEG here and turn it into executable, and it would try its best to run it. It would fail, but it would try. So for files, the X is execute. For directories, the X is for browse. And I wish, let me see. I'm going to try to make an example of this binary bit, right? So we have 3 sets of permissions: read, write, and execute. For, oops. Apparently I can't type tonight. These can be represented in binary by, so you may see on the internet somewhere, if you're doing like following along in like a instructions on how to do something, that you need to set your permissions to 7, 7, 7. And what 7 is in binary is 1, 1, 1. So what you're doing when you set your permissions to 7, 7, 7 is you're granting everyone read, write, execute. I mean, across the board for owner, group, and everyone. And that makes a very insecure file. So don't ever do that. Usually, if you're doing something for Apache, they'll ask you to do a 655. And 6 in binary is 110, and 5 is 101, 101. So you see here, 6 is read, write. This is read, execute, read, execute.
Okay.
Yeah.
So if you put the 7 as low as the 111, that means that's what you don't want to do?
Well, yeah, 7 is everything. Like it's basically removes every restriction from the file. Everyone anywhere can do anything they want with that file.
Okay.
So, and I'm just basically showing the 7s here, and they're not, like, the reason why you type in 7 or 6 or 5 is because that's its representation in binary. You wouldn't type in chmod 111 or 111 111 on a file. You would do chmod 777. And that's just because it's a lot easier to write 7 than it is 111. But on the, in terms of what permissions that 7 gives, 7 translates to 111 in binary, and so that goes to read, write, execute. And the same thing with 6. 6 translates to read, write. 5 translates to read, execute. Some make somewhat sense?
Yeah. Is it so it would be 6, 5, and then that last one be 4?
No, this last one would be 5.
So 6, 5, 5.
Yeah, 6, 5, 5. So in binary, right, let's just deal with 3 bits. That's 0, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, and that's 7. And so that's where, actually I should put its decimal representation here. So, and if you want a file to be read by no one, not even yourself, you can set it to 000. Now it's not terribly useful because if you're the owner, you have the permissions to change the permissions. So the owner has ultimate control. They can actually change the permissions to lock anybody else out. I can't, as a member of the group or as a member of everyone, change the permissions of the file, but the owner can, or root can. Root's the owner of everything, so root can do it. So if you ever see anything like chmod 444 file.txt, that means it's going to be read for everybody. Because read is that first bit, write is the second bit, and executes the third bit. Somewhat sense?
Yeah.
Okay. This is kind of heavy stuff, and it's binary to decimals, always a little confusing the first few times you get into it. But I did a chmod plus x here on this script. If we look at the script permissions now, it's rwx, rx, rx. Now that's another feature of chmod. Say I don't want to specify, I don't really care, I just want to do a chmod plus r. That adds read, chmod plus w is write, plus x is execute. Now, you can also do a minus to remove that access. So I want to make this script, I don't want it executable anymore. I can do a chmod minus x script. Now if I do that ls-l, you can see it remove that permission. And just for thoroughness, we'll do a man on chmod. Change file mode bits. And this goes into the very, very detailed. And you can see here a numeric mode is from 1 to 4 octal digits, 0 to 7. Derived by adding up the bits with values 2, 4, and 1. Omitted digits are assumed to be leading zeros. The first digit selects the user ID, the group ID, and the restricted delegation are sticky attributes. I'm not even going to get into sticky bits because they're interesting. Oh, also forgot to mention, not only can you do plus or minus, but say you want you, not you, not that you, or a group, this would be U for, what does U stand for? I forget. I want to say universal, but set user ID and set group ID. So let's do an ls-l on this. Oops, on this X script, right? And I'm gonna say I'm gonna chmod G plus X. And if I do that, it shows that the group has been added to the execute privilege. So you can get fairly granular either with specifying them explicitly or just modifying them by, what permission you explicitly want to add or remove from the file. Let's do U plus X. What does that do? I thought that would do everybody, but it did owner, apparently. So the user that owns the file, it granted execute to that. I forget what the A for everyone. It is. So this could be U, G, or A, corresponding with owner, group, and everyone or all. I'll put that in there. Just so it makes slightly more sense. Bam. 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 This makes sense, everybody? Sort of? Okay. Good talk. We had that, everybody. Let me make sure there's no questions here in this. No, looks good. I'm still recording audio. That's a good thing. So that's the basics of permissions. They're not super difficult, but they will come into play very, very soon, especially with websites and Squid. Squid is very, very particular, especially with, we'll probably be doing SquidGuard, and it's super particular about permissions on its. Squid, since we're talking about it. Squid is a proxy server, and Squid's pretty cool. There's a lot of really cool things you can do with Squid. It's pretty much one of the most common proxy servers out on the internet. I think between Nginx and Squid, I mean, there aren't a lot of other proxy servers out there that are as big or as powerful. Squid actually works in 3 distinct modes, and from a enterprise standpoint or from a business standpoint, a proxy is what you would use. So say everyone in the entire company, instead of their computers directly going out to the internet, requesting pages and downloading them, they request their web pages from the proxy server. Then the proxy server goes and grabs the information and then caches it on the proxy server. So then when someone else goes to that same page and requests the same thing, they have much faster response. It also works for security, right? So you're not allowing that, and redirects you to, I don't know, a 10-hour video of Hey Ya.
On pink unicorns dancing on rainbows.
Pink fluffy unicorns dancing on rainbows. So there's a lot of power you can do with Squid, and one of the things that we'll be doing for the project is setting up Squid and a redirector known as SquidGuard, which sets up those rules a lot easier than just with Squid itself. It allows you to dynamically say, like, I want these domains to be blocked, I want these domains to be allowed, or I want this specific file name to be banned everywhere, or this specific file hash. You can also hook it up with an antivirus, so you can scan web content as it's coming in and block a virus before it ever gets on your network, instead of dealing with it once it gets in. So Squid's pretty cool.
I think you get around somebody that blocks it by just typing HTTPS.
Sometimes. That's actually an interesting point. Sometimes. There's a technique known as SSL bumping that actually disallows that. But sometimes, and especially SSL bumping, you can actually be a man-in-the-middle attack of saying, oh, hey, you're wanting to go to google.com securely. Oh, let me go download that certificate and present it to you. I'm Google now. And so, no. And if you manually set your proxy as opposed to it will actually take SSL traffic. So, I actually had that issue the other day where someone was doing it.
Does that mean they'll still get to use Google, but you can watch YouTube?
Exactly.
Okay.
So it defeats the whole purpose of having HTTPS, which is why it's a man-in-the-middle attack.
Yeah.
It's considered a man-in-the-middle attack, but, whatever. So that's Squid. I also wanted to go over a little bit of SE Linux. So this deserves a Wikipedia article. Wikipedia. SE Linux is Security Enhanced Linux. This stuff was actually written by the NSA. And it's open source, so at least there's no visible signs of backdoors in it. I'm not saying there aren't backdoors in it, but the NSA uses it on their own stuff. And the NSA does do their stuff pretty well. I mean, they know their stuff. It's the default in Fedora and in CentOS and in Red Hat Enterprise Linux. And it's actually really, really good, but one of the biggest criticisms of SE Linux is it's complicated to use. And I will even admit it's very complicated to use. But it's very, very powerful, too. What it does is it basically introduces the idea or concept of context. So I'm actually going to show the same script, but I'm going to add a capital Z to it. It will actually show the context of the file, which is right here, this unconfined view, object R, and admin home T. And if, I forget what these, what do these stand for? I'm totally spacing it.
Is it a jackal? Jackal.
No, it's not a jackal. U, R, and T. I kind of feel dumb for this. User role and type. So it adds basically a type of role-based access control, which is very, very good, but it's, like I said, pretty complicated to set up, especially because they don't list all the contexts right out to you. So that's unconfined, means it's really not confined to anything, and it's allowed to go into the admin home for object. If I show you a file from bar www.html, no, don't know why I grabbed bar www.html, you can see there's this, the unconfined view and object are the same, but this HTTPD sys content is required for that to actually be served up. Now, for most cases, I'm bringing this up because SE Linux is a pain. And honestly, you don't really have to know what all this stuff means, but I do recommend that you do it right, and you'd have to do some digging on whatever you're doing to do it right. But I will say this. Instead of disabling SE Linux, because that was actually very common in the past, to just disable SE Linux because it was in your way of getting something done, turning it into permissive mode is much more secure than going into completely disabled. And you can see what mode you're in by git enforce. And right now I'm in enforcing mode. So if I change the context of index.html to, I'll just show you an example, right? I have my local web server here, localhost, not WordPress, just localhost. It's not running because probably my web server isn't running. Service systems, CTL, restart, HTTPD, and now we go to localhost and you see Fedora Workstation. If I do a chcon, which is for change context, dash help, if I could spell help right, that would be helpful. I believe it's dash T for type. Yep, it is. Dash T var, what did I have that? Admin home, right? That's the context of my xscript.sh. To that on var www html index.html. Because I'm in enforcing mode, when I refresh this page, it should, I hope it will, break. Yeah. It doesn't see that my HTML, index.html is viewable, and you can see there's an XE Linux security alert saying that it was denied access. And so this could be frustrating if you just copied your index.html into that directory and you're like, well, I want it to work. Why won't it work? It's because of SE Linux. Instead of disabling it completely, what you want to do is do a set enforce to 0, which puts the SE Linux context into a monitoring. So instead of just outright denying it, it'll just log the fact that it should have been denied, and now it works. So we will come into those issues, and instead of just disabling SE Linux outright, we'll just turn the enforcing mode into disabled. To make that permanent, what we'll do is we'll go into etc. sysconfig C Linux. Wow, I can remember things today. And instead of enforcing, we're going to go to permissive. And now if I save and quit, now my system will always be in a permissive mode instead of denying. So I highly recommend, while we're going through these services and dealing with these problems, if you run into an issue where things aren't working and they should be, I would say a vast majority of the time it's because of SE Linux, not letting you do things. So that's it. Oh, probably, I don't know, we are about half an hour today, so I did go pretty quick through that. If you guys want to, for next week, get Squid installed and running. I'm kind of debating whether or not I should do it tonight. What do you guys think? Yay? Shrug? Yeah, you down? Let's do it. All right. Kind of anticlimactic. Yum. Install Squid. It's small. It's only 2 megs.
Yum install Squid?
Yum install Squid. It's very small. Yum space install space Squid. Yep. It's 2 megs. It's tiny. Wow. Grand scheme of things, it's tiny. That's like 2 floppy disks.
Floppy disks.
Are you connected to the network? Is that why yours isn't working? Either of yours?
It says you need to be root from this command.
Yeah, you gotta be root. sudo-i. Yep. Get to root. Yeah. Squid's really small. It's really quick. We're going to go and I'm going to do a systemctl restart Squid. It would be helpful if I spelled systemctl correctly. I'm very good at typing. Yeah. So it's running. How do we know it's running? We do a status. And it is running. How do I use it? I just asked for you. Well, there's a couple ways, and actually this is a really cool way of seeing it. First off, since no one really knows what port it runs on, we're going to check the configuration. I'm going to go to vim etc. Squid.conf, and I'll show you what port it's running on. If you look right here in the config file, oh, excuse me, it says Squid normally listens on port 3128. What do you know? HTTP port is set to 3128. So if I go out of Vim and I do a netstat -amtp and I grep 3128, you can see that on IPv6 I'm listening on with Squid on port 3128. So let's fire up Firefox because I have Foxy Proxy set up. Foxy Proxy is an awesome plugin if you play with proxies a lot. Which, if you have to bounce around the internet, like to Japan and like China, and like get around things for reasons, you know to use Foxy Proxy. It's awesome. So I'm gonna change this. Actually, I'm gonna create a new one. I'm gonna cancel this. I'm gonna add a new proxy. I'm gonna say localhost port 3128, and that's all I need to set up. If you do this not in Foxy Proxy, it's under this, Preferences, Network Settings. And mine takes me there, but yours will take you to a page where you can set your proxy. Doesn't matter for this, you don't need Foxy Proxy. I like Foxy Proxy though. I don't pay for it because I don't like paying for anything unless it's really good. Minecraft I pay for.
Adblock?
No, I don't pay for AdBlock because I can AdBlock with Squid for free. Free 90 free. So anyway, now I'm set to use, I'm going to use proxy localhost 3128 for all of my stuff. So now if I go to, let's go to server fault. It goes to server fault. Not terribly complicated or crazy, but how do I'm not really doing it justice in terms of how numbers are stored on processors, but a 32-bit computer, you're dealing with 32-bit numbers. And 32-bit numbers